Good morning. So in this video we will see the analysis of the beam element. So this is the question given. There is a cantilever beam. The beam is fixed at the one end. It is subjected to UDL of 1000 Newton per meter and its span is 1000 millimeter. At the free end there is a point load of 1000 Newton. We have to draw the shear force diagram and the bending moment diagram and also to find the maximum deformation at the free end. So this is the ANSYS user interface. We will start with the file, clear and start new. Then again go to the file, then save as. Okay, select the directory, select the folder. Now here change the name. So give the name for the beam analysis. You can give any desired name. Okay. Now here click save DB. Now start with the preferences. Select the structural. Then go to the preprocessor, element type, add element, link element. So it is a 3D finite or the beam element. Okay. So as we have to model the beam, so select the beam and 2 node 188. Okay. Close. After the element, no need to add the real constant. Just go to the material property, material model, structural, linear, elastic and the isotropic. Give here Young's modulus as a 200 e to the power 3. So it is a 200 into 10 to the power 3 Newton per millimeter square. Poisson's ratio as a 0.3. Okay. As the beam has uniform material, so we need just one material. Next, now select the section, go to the beam and common section. So give the name as a beam 1, you can give any name. Select the subtype rectangular cross section. Now here B and H, so you can specify the B. So it will be given in your problem. So I will assume this right now. So let us take this as a 30 and the height as a 60. Okay. Next, now after this section, go to the modeling, create key point in active coordinate system, create the first key point at 0, 0 and 0, apply, create the second key point, so you can see at 1000 millimeter, so this is 1000, apply, and the third key point, so it is 1500 millimeter, apply. Okay, so we have created the 3 key points. Now after key point, create the line, straight line, select the key points. Okay, so we have created the line. So after every step, you take the screenshot and then you can add this image in your report. So we have created the line element. Now we have to mesh it. So go to the meshing. First select the mesh attribute, default attribute. As the material number, we just have 1 and section is 1. Okay. Now go to the mesh tool and select the line. Select here first line. Okay. Now here instead of 1, we will increase the number so that we can draw a smooth bending moment diagram and the shear force diagram. So I have taken the element as a 30. Even you can select 50. So if I select here 50, okay, raise the hidden tab, again mesh, select the same line. Okay, so first line meshing is completed. Now again go to the mesh tool, select the line, select second, it is not visible, but select this. Okay, number is same 50. Okay, raise the hidden, mesh, again select this and okay. So now we have applied the mesh. If you want, you can visualize the element. Go to the plot control, style, size and shape. Okay, so this is the element. Just select here fit view. So meshing is completed. Now apply the load and the boundary condition. So define load, apply structural displacement on nodes. So on the left node, as it is a fixed, so all degrees of freedom will be 0. Okay, so this is completely fixed. Now here we have to apply a point load. So apply the force. I will select the key point, so it will get easily selected on the key point. Select here. Okay, now the load in y direction and give the value minus 1000 Newton, so it is negative y. Okay, now here we have to apply the UDL. So select here pressure. UDL is a pressure on the line, and select here on the beam. Okay, now here to select the region, select here a box and start here. So this is the first element. Okay, now here the load key will be 2. First load was a point load, second will be the UDL, and its value is, if you see the diagram, it is a 1000 Newton per meter. So if I convert this into Newton per millimeter, it will be 0.1. So give here value as a 0.1. I and J, it is a starting point of UDL, it is the end point of UDL. So UDL value. Click OK. Now you can see the loading. Now here you take the screenshot. And you can add this into the report. Okay. Now go to the solution, solve current LS. Solution is done. Now if you want to see the deformation, go to the plot result, deform shape, deform and undeform. So you can see the deformation. You can add this diagram in your report. Select the contour plot, nodal solution, deformation, deformation in y direction. So this is the maximum bending. Okay, so maximum deformation is a minus 42 millimeter. Now we have to draw the shear force and bending moment diagram. For that we have to define one element table. So define table, add. Now here we have to add some constant which are predefined in the ANSYS FPDL. So after define table, select the last option by sequence number. SMISC, we have 4 constant. One is a 3. Apply. It will get added in the table. Again by sequence number, constant will be 6. Apply. Next constant is 16. Apply. And last constant is 19. Okay, so we have 3, 6, 16 and 19. The combination of 3 and 16 will give the bending moment diagram, and 6 and 19 will give the shear force diagram. Close. Now go to the plot result, contour plot and line element result. Okay, now here select the first as a 3. So 3 and 16, this is the bending moment diagram. Okay, so this is what the bending moment diagram will look like. You can verify the result by the strength of material procedure. Maximum bending moment is a minus 5000. This is Newton millimeter. Again go to the line element. You take the screenshot for the bending moment diagram. Now select the combination 6 and 19. Okay. Now this is the shear force diagram. Okay. So this is how we can draw the shear force and the bending moment diagram. And if you want the values at each node, then you can go to the list result, then the nodal solution. This is degree of freedom. You can check any values. This is the deformation y component. Okay, so here you can get the maximum value as a minus 42. This is at the node 52. This is the element table data. Select element 3 and 16. So this will give the bending moment values. Okay, so you'll get all the bending moment at different nodes. Okay, so here maximum value is a minus 5000 Newton meter. Okay, so in this way you can perform the beam analysis for shear force and bending moment.